So this is the 25th session on rigid body kinematics. Okay, 25th video. This is again in continuation of the 24th video. So before going ahead, I am again repeating it again that if you the videos which are being made, you can use them to study the entire thing for your syllabus from this video itself. You don't have to take up any other book. You don't have to go anywhere else. You don't have to go to any coaching institute. Okay. So this you will keep into mind. If you have any doubt, you put your doubt in the comment box. I'll discuss it, okay, and let you know. Fine. So now I'll take up some more problems on rigid body kinematics, SRC procedure for acceleration. This is in continuation of the 24th video. So I'll take up some more problems here, okay, fine. The problem is this. P1, P2 is a rigid rod. P1, P2 is a rigid rod of length 2 meter, which rotates in a vertical plane with respect to ground, noted as G in short. Okay. In each case, all the details are given. Find the acceleration of P2 with respect to ground G in I hat J hat notation. In I hat J hat notation, okay. Coordinate system in each case is like this as usual. X axis rightward, Y axis vertical is the origin of the coordinate system. Okay. So I'll take up some more problems on this concept. Okay. Fine. So part A. Part A is this. This is P1. This is P2. Okay. Length of the rod is given to be 2 meters specified. Acceleration of P1 is given to be 10 root 2 meter per second square with respect to ground. Angle which this acceleration makes with the rod is 45 degree. Angular speed omega of rod is 4 radian per second, and beta is also given to be 5 radian per second square. Both are with respect to ground. Okay. Coordinate system is as specified here. Now you have to find a P2G. Acceleration of P2 with respect to ground at the given instant. That we have to determine. Okay. Again we apply the SRC procedure for acceleration. Okay. So SP arrow P1, OP arrow P2. Okay. Now what we do? We draw the line joining SP and OP, which is simply the line P1 P2, which is vertical. Then what do we do? We give the acceleration of selected point P1 to other point P2. So to P2 we give what? 10 root 2 meter per second square at an angle of how much? 45 degree. Now what do we rewrite on the sentence? Omega is clockwise. So P2 moves in a clockwise circle with center at P1 and radius 2 meter. So we give two accelerations to P2. Omega square r to P2 towards the selected point P1. Omega square becomes 16 into r becomes 32 meter per second square in downward direction towards P1. And we give beta is clockwise. So we give r beta to P1 in clockwise sense, corresponding to clockwise beta. Now if P2's center is here, if center is here, this one, and r beta should be given a clockwise towards clockwise beta, r beta should be clockwise. So with center as this and for beta to be clockwise, r beta should be in this way. So r beta is in this way. R is 2, beta is 5. So 10 meter per second square. Okay. Now acceleration of P2 is the vector sum of these three terms. So A2G meaning what? Acceleration of P2 with respect to ground. Now this I write first this one, 10I along x-axis. This is along minus j hat. Now this I break into components. J in this way, I in this way. So 10 root 2 cos pi by 4 into j hat. Cos pi by 4 becomes 1 by root 2 into j hat. 10 root 2 into sin pi by 4. 1 by root 2 into I hat. Okay. This set up the first column. Okay. So A2G becomes how much? A2G becomes 10 I hat plus, so root 2 cancels, 10 I hat plus 10 I hat. It becomes 20 I hat. And this becomes 32 minus j hat, root 2 cancels. 10 j hat minus 32 j hat minus 22. Minus 22 j hat meter per second square. This is therefore the required answer. Alright, fine. Now I take part B of this question. Part B. Part B is this. This is P1, this is P2. Okay. Coordinate system is again as usual, as was same in part A. This is 2 meter rod length. Expression of P1 is 10 meter per second square at an angle of 60 degree. Omega is this 5 radian per second clockwise with respect to ground. And beta is this 6 radian per second square with respect to ground. Now we have to find AP2G. Again we apply SRC procedure for acceleration between the points P1 and P2. So selected point becomes P1. Other point becomes P2. Alright. Selected point becomes what? P1. Other point becomes what? P2. Alright. Fine. Now what do we do next? I draw the line joining SP and OP, which is this line itself. So P1 and P2. Okay. 2 meter. Now first action, what do we do? We give the acceleration of selected point P1 to other point P2. So P2 I give acceleration of how much? 10 meter per second square at an angle of 60 degree. Alright. Now I give two accelerations to P2. Omega square R to other point P2 towards selected point P1. Omega square becomes 25. R becomes 2. 25 into 2, 50. So I give acceleration of 50 meter per second square to P2 towards P1. Now beta is anti-clockwise. Now for beta to R beta should be such that P2 undergoes anti-clockwise tangential acceleration of R beta with center at P1. So R beta, since beta is anti-clockwise, R beta should be in this way. R beta should be in this way. R is 2, beta is 6. So it becomes 12 meter per second square. Okay. Now acceleration of P2 with respect to ground is a vector sum of these three terms. So I write it as A2G. Now this term is first 12 times minus I hat. This is 50 times plus j hat. Now this I break into components. This is 30 degree by geometry, 90, 60, 30. This is 10 cos 30 degree. Cos 30 becomes root 3 by 2, I hat. And 10 sin 60 degree minus j hat. 10 cos 60 degree, 10 by 2 minus j hat. Okay, so A2G is the vector sum of these four terms. Now how much will this be? Here you see this becomes 5 root 3 minus 12 into I hat. And this is 50j minus 5j plus 45j hat meter per second square. Okay, plus 45j hat 5 root 3 minus 12 I hat plus 45j hat meter per second square. This is therefore the required answer. Fine, is it clear? Alright. See, direction of R beta should correspond to sense of beta. If beta is, for example, if beta is anti-clockwise, then this is the center. R beta should be in such way that beta corresponds to anti-clockwise. This is the center, so R beta should be in this way. Then it should be, R beta should be in, oh I made a mistake here. R beta should be, no, sorry. R beta anti-clockwise, no? I made a calculation mistake here. I rectified. Beta is anti-clockwise, so R beta becomes 12. Now center is here. Beta anti-clockwise, so R beta should be in this way. 2 into 6, 12. 12 in this direction. I'm very sorry. Okay, just rectify it. Okay, this one plus I hat. Okay, now it's alright. Now it's alright. Okay, fine. So since beta is anti-clockwise, so R beta should be such that it corresponds to anti-clockwise beta with center at P1. So beta anti-clockwise R beta should be in this sense, this way, not opposite. Okay, fine. So these two questions I have taken. I hope it is alright. Fine. Now I have this one. Let's take up another question on this rigid body kinematics for acceleration. Okay. P1, P2 is a rigid rod. P1, P2 is a rigid rod. Okay. Of length 4 meter, which rotates in a vertical plane with respect to ground. All right, fine. With respect to ground. At the given instant, accelerations of P1, P2 with respect to ground G are as shown. Okay. In each case, find the angular speed omega and its angular acceleration beta with respect to ground, G for ground. Okay, fine. This now I'll rub it. Okay. So part A. Part A is this. This is a rod. This is a rod P1, P2 whose length is 4 meter. Acceleration of P1 is given to be 10 root 2 meter per second square, 45 degree. And acceleration of P2 is given to be 10 meter, no, I'll write this as 8 meter per second square at an angle of 60 degree. Both these accelerations are with respect to ground. Okay. Now we have to tell in both cases what is the angular speed and angular acceleration of this rod with respect to ground. You have to specify both the magnitude and sense both. Okay, fine. So now how to proceed? So what do we do? Beta we find directly, as was discussed in the 24th video. 24th video, yes. In the 24th video, relative velocity, beta was given to be relative normal acceleration by separation. The proof of this was given in the 24th video on rigid body kinematics. Relative normal acceleration by separation. Now, what is the normal acceleration of P1? Component of A P1G normal to line P1 P2, which is simply 10 root 2 sine 45 degree in this way. So relative normal acceleration of P1 becomes normal acceleration of P1. Normal acceleration of P1 is the component of this acceleration of P1 with respect to ground in a direction normal to line P1 P2. That is simply 10 root 2 sine 45 degree. 10 root 2 sine 45 degree becomes 1 by root 2. That is, it becomes 10 meter per second square in rightward direction. So what is the normal acceleration of P2? That becomes 8 sine 60 degree, component of 8 P2G, this one, normal to line P1 P2. That becomes 8 sine 60 degree. 8 root 3 by 2. That is 4 root 3 meter per second square in leftward direction. Okay, fine. Now I rub this one. Now these two normal accelerations are in opposite direction. So from the theory of relative acceleration between two moving points, beta will be simply sum of these two. They are in opposite direction. So relative normal acceleration will be sum of these two normal accelerations, magnitude by sum. 10 plus 4 root 3 by 4 radian per second square, and this should be in anti-clockwise sense because normal acceleration of P2 is left and normal acceleration of P1 is right. So resultant becomes anti-clockwise. This is one answer to the question. This is one answer to the question. Okay, fine. Now we also have to find omega. We also have to determine the value of omega. Fine. So now how to determine the value of omega? So we take SP as the selected point P1, P1 as selected point, and P2 as the other point. Okay. So now what do we do next? SP arrow P1, OP arrow P2. Okay, fine. So what do we do? SP arrow P1, OP arrow P2. So first what we do? We give the acceleration of P1 to P2. First step, acceleration of P1 to P2. P1 is 10 root 2, we give 10 root 2 to P2. And now we give omega square r to P2 towards the selected point P1. Omega either this way or this way. Omega square always towards P1. That I've already told. Irrespective of sense of omega, omega square r is always given to OP towards the SP. Okay. So how much we do? Omega square into 4. Omega square into 4. Alright, fine. This how much? 45 degree. So now what do we do? Acceleration of P2 in this direction is how much? 8 cos 60 degree. Acceleration of P2 in this direction is along this line P1 P2 will be from how much? 8 cos 60 degree. That is 4. Which is the vector sum of component of these two acceleration in this direction. 10 root 2 cos 45 degree minus omega square into 4. So 4 omega square becomes 6. Omega becomes root 3 by 2. Root 3 by 2 radian per second. Root 3 by 2 radian per second. This is going to be the value of omega. Root over 3 by 2 radian per second is the required value of omega. Okay. But we cannot tell anything regarding the sense of omega. Why? Because nothing has been said regarding the velocities of P1 and P2. So we cannot say anything regarding the sense of omega. But its magnitude is going to be root under 6 by 4, root under 3 by 2 radian per second. Okay. But we cannot say anything regarding the sense of omega. For that we also have to know the velocities of P1 and P2. Since nothing is specified regarding the velocities of P1 and P2, so we cannot say anything regarding the sense of omega. We can only say that its magnitude is this much. Alright, fine. Alright. So this was the 25th session of rigid body kinematics. Okay. So I'll take up one more problem on this based on this concept. Okay, fine. I'll take up one more problem based on this concept. One more problem I'll take up. Okay. One more problem based on this concept I'll take up. So this is this one. See, this is the rod P1, P2. Okay, fine. And this is 20 root 2 meter per second square, 45 degree angle. This is 4 meter rod length. And this is equal to say 8 meter per second square at an angle of 60 degree. Again we have to specify the omega and beta of this line P1 P2. omega and beta both. So beta we find as usual. Beta we find using the formula relative normal acceleration by separation. Relative normal acceleration by separation. Now, what is the normal acceleration of P1? Normal acceleration of P1 becomes 20 root 2 sine 45 degree. Sine 45 degree becomes 1 by root 2. 20 meter per second square in rightward direction. Now, what is the normal acceleration of P2? That is 8 sine 60 degree. Sine 60 degree becomes root 3 by 2. 4 root 3 meter per second square, that is also in rightward direction. So both are in same direction. So relative normal acceleration becomes relative of these two. They are in the same direction. So we have to take difference. So this becomes 20 minus 4 root 20 minus so 20 minus it becomes 20 minus 4 root 3 upon 4. So this becomes 5 minus root 3 radian per second square. Okay, fine. Is it clear? All right. And what about omega? Omega also you find using the same method. We determine omega also using the same concept, this error bit here. So again we apply SRC procedure for acceleration between P1 and P2. This is P1, this is P2. SP arrow P1 and OP arrow P2. Fine. Now I give the acceleration of P1 to P2. Acceleration of P1 is given to be how much? 20 root 2 meter per second square. At what angle? 45 degree. Now in second step I give omega square r to P2 towards selected point P1. R is how much? 4. Omega square becomes 4 omega square. I am not showing that r beta term, that's not relevant. We are only interested in this direction. Okay. I'll show it. Okay, no problem. Okay. And beta. So sense of beta you can see in this diagram. Sense of beta is in clockwise sense. Sense of beta is in clockwise sense. You can see from this. This is more anti-clockwise sense. Sense of beta in this diagram is in anti-clockwise sense. See, this is more, this is less. Same direction. Both the normal accelerations are in same direction. This is more. So sense of beta will be anti-clockwise. I am showing it for the sake of clarity. If you don't show, there is no problem. We are only interested in this direction in this problem. Okay, but still I am showing it. So for omega to be anti-clockwise, r beta should be in such that omega is anti-clockwise. So r beta becomes how much? 4 into beta. Anti-clockwise becomes this much, 4 beta. So acceleration of P2 is the resultant of these three, this and this. But we are only interested in this direction. Alright. So acceleration of P2 in this direction will be 8 cos 60. 8 by 2, cos 60 half. That is same as 20 to 2 cos pi by 4. Cos pi by 4 becomes 1 by root 2. Minus it becomes how much? 4 omega square. So 4 omega square becomes 20 minus 4, 16. Omega square becomes 4. Omega becomes 2 radian per second. That is the required answer. Okay. Again, we cannot say anything regarding sense of omega because nothing had been said regarding velocities of P1 and P2. So that we have to specify. So this is the required answer. Okay. So this was the 25th session on rigid body kinematics. Okay. So this also I discussed problems on this SRC project for acceleration. Alright. So next video again I'll take up 26th video. I'll take up the pure rolling from acceleration point of view. I'll discuss. I'll discuss pure rolling from acceleration point of view. Okay. There are some similarities with velocity and some differences with velocity also. That will specify. Okay. So you go through them properly. Okay. If you have any doubt, give that write down the doubt in the comment box. I will look into it and discuss it. Okay. Fine. So you properly go through them. I'm telling you, if you understand this much, you don't have to go to any institute at all. You just see them and you directly take up the problems from any book or source wherever you want to. I'm sure you will be able to solve most of them. Okay, so I close it here.